AI explosion is everywhere and there are tons of fancy products built with AI. Today we are going to build a simple yet very powerful application of AI. With Supabase's vector database and OpenAI's embeddings, we will build a semantic search application. It's going to be cost effective, easy to start and easy to manage. Let's start. Hello guys, this is Batuhan from Maker. Today we are going to build semantic search application. In our application we have a simple search bar and it searches through movies list, and on the left side you can see our movies data. So let's try search some keywords like this. For example, we can search Walter White here and it will bring the Breaking Bad as a first result, right? So let's check our data of Breaking Bad. In our plot, there is no keyword like Walter White or in our title, but AI can understand this similarity between Breaking Bad and the Walter White, even if there is no keyword like Walter White in our data. This is so cool. Let's try another keyword, Marvel. As you can see, it brings all the Marvel films, movies from our data. But again, in our data, there is no Marvel keyword. But AI can understand the similarity between the query and the data. I'm going to show you another example. I think this is cooler than this. Let's try search drug dealers and it will bring all the movies as we expected, right? But if we try this in another language like Turkish, it will understand the query and calculate the similarity between the query and the data. Even if our whole data is in English, AI can understand Turkish query and calculate this similarity. I think this is so cool. Let's try another example like superheroes. There is no keyword in Luke Cage like superheroes. You can see that. We have a keyword super strength, but it's not superhero. I'm sorry, there is a keyword called superhero. Okay, but let's try in Turkish again. As you can see, it brings all the related movies based on this keyword. This means that superhero in Turkish. I think this is so cool because we don't have to translate our data into another language to make our search functionality works. And also, we don't have to manage different data sets like Turkish data set, English data set, or in another languages. I think it's easy to manage and very powerful feature of AI. And today's video, I'm going to show you how we can build this kind of application with Supabase's vector database and OpenAI's embeddings. To build this application, I think first we need to understand how this search function works behind the scene. in our vector database, we have our movies as embeddings, as vector. And from our application, we get the search query and create another embedding based on the query. And after that, we calculate the similarity between these two embeddings. I mean that we run a function which calculates the semantic similarity between the query and movie. And after that, we rank our results based on their similarity score. If it's above the threshold, we brings them as results. For that purpose, first we need to create our embedding database, vector database with Supabase. And we need to fill this database with embedding data, right? For that purpose, we should create embeddings for our movie data. Then we can fill our vector database. And lastly, we need to create a search index to make search queries faster. Then in our front end, we need to get our search query. Then we will create embedding based on this query. And we will calculate the relation, semantic relation between query and the movies. And if there is related data, we will bring those data as result. Since our application is a Next.js 13 application, I will build this logic in a root handler. In this root handler, first we need to create our OpenAI client, but for this we first install yarn add OpenAI package. With this package we can access the OpenAI client, and to configure our client we need to get our OpenAI API key. To get our API key, we can simply go to platform.openai.com, and from our profile we can click view API keys and we can create new API key like this. But I already have maximum number of API keys, but you can generate or you can delete one of them if you don't use. Okay, cool. And you can access your API key with your environment variable like this. Cool. Now we have created our OpenAI client, right? With this client we can create embedding. To create embedding, first we will need our movie data because we are creating our embedding based on our title and plot. We get our movie data from our request body and we pass this data into OpenAI client. In OpenAI client there is a helper function called create embedding, and you can choose your model like this. This is the cheapest and strongest model for creating embeddings. And you can pass your input like this, movie.title and movie.plot. Okay, once we have our embedding, we can insert this movie data into Supabase, right? But first we need to install Supabase client. You can simply install this client like this, yarn add Supabase /supabase-js. like this. And once you install this library, you can create a client, and you need to pass your Supabase URL and Supabase public key into it to use this client. Let me show you where you can get those keys. In the project settings, you can get your URL and also your public key like this. And you can get these keys as environment variables. Okay, cool. Now, since we created our Supabase client, we can insert data, right? But first, we need to create this table in our Supabase, in our Postgres database, right? And as you can see, this table has embedding column, but this column has a special kind of type called vector. Let me show you how you can create this type of columns in your Supabase, in your Postgres database with Supabase. To create vector database in Supabase, first you need to enable a Postgres plugin called Vector. In your database section, you can find this plugin in the Extensions tab. You can simply search Vector and you need to enable this plugin. When you enable this plugin in the schema that you want, you can create tables with the columns which has the type of vector like this. In our movies table, we have regular columns. They have the text type, but the embedding column has a special type called vector. You can create this embedding too, and you need to choose vector type. You can simply create this column and store your embeddings in Supabase. Okay, cool. Now we can fill our database with the data that we have, the movies data, right? We can use this root handler in our application like this. We can create a logic, create a function which has a loop, and it calls this endpoint for each movie. With this function, we can fill our database. You can build your own logic. You can build this logic in any way, but I want to make it simple for you. In our root endpoint, as you can see, first we need to create embedding, and after that we will insert this data, movie data, with the embedding in our Supabase database. Okay, cool. Now we have our data and our embeddings. Now we need to find a way to create embeddings with our search queries. How we can do that? To make this happen, we can create another root handler in our application. And in this root handler, first we need to get our query from our request. And we first create our embeddings with this query. And after that, we will use our Supabase client to run our search movies function. This is a custom function that we have created with Supabase, And we can call this function with Supabase client like this, Supabase client dot RPC, and we need to pass the function name and the arguments, and it will bring the results, and we can return these results as our response. But first we need to create this function in Supabase. Let's go to our Supabase dashboard, and in our SQL editor we have a search function. In our function we simply get the query embedding as an argument. We get the threshold for similarity and the match count. And then we returns table. We returns the result as table with these columns. And in this function, we simply search based on the similarity of movies embedding and the query embedding. And if they are above the threshold, as you can see, we define our threshold 0.75 here. If it's above this threshold, it will return as result. But we only want 3 results. You can change these numbers based on your need. For example, you can change this number to see how results change, because sometimes with some data and some queries, low numbers are good, but for some data and some queries, the high numbers are good. You need to find your right number to make this search function more reliable. Okay, cool. After we find our results, we will return our results in this function. You don't have to learn SQL for this purpose. You can just copy this function that I put into SQL folder in this project. You can find this function in the folder called SQL. Also, you can find the create table function as well as create index function. And you can change based on your need. For example, you can change the table name, the other columns, or etc. You can build your own function for that purpose. And second, we need to create our index for our vector database, our movies table, because as our movies table grows, for example, it has 10,000 records, we will see that our search query is getting slower, but we need to make it faster, right? That's why we can create a search index like this, and it will sort our movies based on their similarity in this index. Okay, cool. Now we can check our search route again. As you can see, we are calling this function, the search function in our root like this, Supabase client.rpc, search movies, and search movies, and we pass our arguments like this. And if there is data, we simply return this data as result. And let's check our search page. Give me a second, please. And okay, this one. Oops, sorry. Okay, cool. And in this page, as you can see, we have only this search bar and the movies list. In our search bar, we simply get our query, and when we press the enter button, we run our search function. I built this logic with Jotai. Jotai is a state management library for React, and it's very powerful. If you want to learn more about Jotai, you can check my previous video that I will put on the top of the screen. But we can check this in a quick way. In our search handler, we simply fetch our root like this. We pass our query and we wait for the response. And when we have the response, we change our movies list like this. Walter White. Once we get the data, we simply change our list state. And when we clear it, we return back the initial list of movies. Okay guys, I think that's all. You can check the source code. You can find the source code below in the description. And I think that you can improve, you can build a better version of this semantic search in your own application. For example, you can cache the search queries with maybe SWR, and you can prevent creating embedding for the same queries. For example, as you can see, we search this Walter White keyword, and every time we search this keyword, it's create a new embedding for this keyword. But actually, we can cache this result in client, and we can bring this result in a faster way and cost-effective way. Also, we can cache this query and its embedding in a global cache store like Upstash, and we can use those queries and embeddings even if another user use this query, right? We can create a global cache store, and we can use this cache store before creating a new embedding for this query. We can check this store and use that embedding to run our search functionality. Okay, cool. Thank you for watching this video, guys. I hope you enjoyed this video, and if you enjoyed this video, please hit the like button and subscribe my channel.